By the end of this video, you'll know how to use Fusion 360 to split up your large STL files for easier 3D printing. This tutorial has two main workflows, depending on what type of model you're working with. The first workflow I'll cover is how to split STL mesh files. In other words, a lot of Fusion 360 users import an STL file from Thingiverse, and they need to slice the file into smaller pieces so it fits the size of their 3D printer's build plate. For the second workflow, I'll show you how to split up your model if you built the model directly in Fusion 360, or if you've imported a solid body, such as a step file. This method has similar procedures, but will be working in a different workspace. Also, be sure to stick around until the very end of this tutorial, as I'll show you a trick or two that will help you make joints so each 3D printed part fits together firmly. Before we get started, head to this tutorial's resource page at productdesignonline.com/9. That's productdesignonline.com/9. I'll start off by showing you how to split up this Einstein mesh file that I grabbed from Thingiverse. I'll select the measure tool in the toolbar. Then I'll select the bottom of the model and the top of the model. You'll see that this model is fairly large with a height of over 1200 millimeters. This model is too large to print on most consumer level printers at its current size. So let's take a look at how to split the model into smaller pieces. Because this is a mesh file, we'll first need to enter the mesh workspace, which will let us access some additional tools that only work with mesh files. If you select the workspace drop-down list, you'll see that the mesh workspace option is not available. To access the mesh workspace and its tools, you'll first have to turn it on in your preferences. I'll select my username in the upper right-hand corner. Then, I'll select the Preferences option. This opens up the Preferences dialog box. From there, we'll need to select the Preview tab on the left-hand side. You'll then see the Mesh Workspace is a preview option as its functionality is still being beta tested. So to turn on the Mesh Workspace, you'll have to select the checkbox, hit the Apply button in the dialog, and then the OK button. Then you'll have to restart your copy of Fusion 360 to get the changes to take effect. After restarting your Fusion 360, you'll see the Mesh Workspace still isn't available in the Workspace drop-down list, and that's because we're still in parametric modeling mode. We'll have to enter direct modeling mode, which doesn't capture the timeline history down below. Now, this is required because of the complex nature of mesh files and the fact that Fusion 360 cannot simply record each action that we take. To enter direct modeling mode, simply right-click on the top-level component of your file. Then select Do Not Capture Design History. You'll then get a warning message that Fusion 360 will no longer capture your model's history, which we're okay with, so I'll click the blue Continue button. If I now select the Workspace drop-down list, you'll see that the Mesh option is available. I'll select the Mesh Workspace option, which then gives us access to the unique mesh tools. If you click on the Modify drop-down list, you'll see that there is a Plane Cut option. Now, this is the tool that we'll use to cut the model into pieces. Now, the Plane Cut tool lets you use an interactive plane, which opens up after you select the mesh body. Now, the interactive plane can be moved around. However, I find that it works best to first create some construction planes exactly where you want to split your body, and then we'll reference them instead of using the interactive plane. To do this, I'll make sure the origin planes are turned on by selecting their corresponding light bulb in the Fusion 360 browser. Then, I'll select the offset plane option in the toolbar. I'll select the YZ origin plane as the surface to offset from, and I'll drag the blue single directional arrow over. I want this plane to be in the center of Einstein's face so I can split it down the middle. I'll type out 540 millimeters for the offset distance. If you're following along with your own model, then you'll have to enter your desired distance based on where you want to split the model. Lastly, I'll click the OK button. I'll now select the Modify drop-down list in order to activate the Plane Cut tool. You'll see the first option in the Plane Cut dialog box is to select the mesh body. This is where you'll need to select the mesh body of your model. In this case, I'll select the Einstein body. The next option in the dialog box is the plane selection. I'll click on the plane selector and then I'll select the offset plane that we just created. In some scenarios, you may even find it beneficial to select the construction plane in the Fusion 360 browser, ensuring that you don't accidentally click something else. You'll then see that we need to choose the cut type. If I select the drop-down list, you'll see that there are 3 different options listed. The trim selection will delete 1/2 of the body, trimming it away. The split faces option will split the faces at the intersecting plane. However, they will keep the body intact as one single body. This split will also create a new face group on one side of the split. In our case, we want to completely split the model in half, so I'll select the second option, which is split body. The split body option will split the mesh body into 2 completely separate bodies. Lastly, before we click OK, we'll want to choose the fill type. Now this drop-down list also includes 3 different options. The no fill option leaves an open hole or boundary at the cut. The uniform option fills the holes with new faces of the regular shape based on how the mesh triangles line up. Last but not least, the minimal option fills the hole with the minimum number of faces possible, which usually results in long, thin mesh faces. In our case, we want the bodies to have flat sides so they can sit on a 3D printer's build plate. Therefore, we could technically use the uniform or the minimal options. However, I often recommend using the minimal option. This will reduce the file size with a smaller number of faces, while also making it easier for Fusion 360 to process. It's also important to point out that you can toggle open the numerical input section, where you can translate or rotate the cut plane using numerical values. After selecting the minimal option, I'll click the OK button. Depending on the complex nature of your mesh file, this may or may not take a few minutes for Fusion 360 to process. Once it is done, you'll notice that there are now 2 mesh files in the bodies folder of the Fusion 360 browser. At this point, we can cut the bodies into more pieces. Let's take a look at using the interactive plane. I'll right-click in order to select Repeat Plane Cut. Then, I'll select the body on the left side. You'll see the plane manipulators automatically appear, and we can move them around to reposition the cutting plane. However, as I described earlier, I find this method to be harder to work with, and I typically like to create construction planes that I can reference with the plane selector. You'll see this will cut the bust in the vertical direction. I'll simply drag the blue single directional arrows around until this plane is located near the beginning of Einstein's ear. Then, I'll click the OK button to see the results, as the options are set to the settings that we previously used. As you'll see, we now have a third mesh body in the Fusion 360 browser. At this point, you can continue to slice the model into sections as you deem necessary to fit the parts on your 3D printer's build plate. You'll then be able to right-click on each mesh body in the Fusion 360 browser to save it as an individual STL file. Before we move on, I should also point out that this next method I'm going to show you will also work on mesh files, not just solid bodies. However, I recommend that you use the mesh workspace when splitting STL mesh files, as you'll have more control over the mesh faces. Let's now take a look at splitting up a solid body file that was either built in the model workspace or a model that was imported from a STEP or F3D file. For this demo, I'm going to use a bookrest that I modeled in Fusion 360, which is too long for the 3D printer's build plate. Therefore, I want to split this model down the middle so it's printable. Now the process is going to be similar to the mesh workspace. However, you'll notice that the tools will function in a different manner. I'm going to first create a construction plane, which I'll then reference with the split body command. I'll select the construct drop-down list. Then I'll select the offset plane option. I'm going to select the bottom origin plane, and then I'll drag the blue single directional arrow towards the top, leaving it at 3 inches, which is about the middle of the design. Then I'll click the OK button to confirm the plane's location. Next, I'll right-click in order to select the Repeat Offset Plane option. I also want to create a plane that splits this model in half in the vertical orientation. I'll select the XY origin plane, and then I'll enter an offset distance of 3 inches, putting this plane in the center as well. At this point, we'll need to activate the split body command. I'll select the modify drop-down list, and then I'll select the split body command, which is located near the middle of the list. You'll see in the split body dialog box that we first need to select the body to split. In our case, I'll select the bookrest body. However, it's important to note that you will need to select all the bodies that you want to split. I only have this single body, but you can select multiple bodies at once. Once your bodies are selected, you'll need to select your splitting tool or plural tools, as you can select multiple tools at once. Most of the time, you'll be using construction planes. However, you can also use other bodies or faces as the splitting tools. I'll go ahead and select the top offset plane. Then, watch what happens as I try to select the second offset plane. You'll notice that Fusion 360 doesn't allow this because the tools would collide with each other. Therefore, it's important to note that you can have more than one cutting tool, but their paths cannot cross one another in the same feature. For now, I'll deselect the bottom plane. Then I'll click the OK button. You'll now see in the Fusion 360 browser that I have 2 different bodies in the Bodies folder. I can now right-click to select Repeat Split Body, and this time I'll select both of the bodies. Then I'll click on the Splitting Tool selector, and I'll select the other offset plane. Finally, I'll click the OK button in the dialog box to confirm the results. You'll now see that I have 4 different bodies in the Bodies folder, allowing me to 3D print this design as 4 different parts. At times, you may even find it helpful to move pieces away from each other as you split them apart. To move pieces around, simply select the body that you want to move by clicking on it in the Fusion 360 browser. Then, hit the keyboard shortcut letter M as in Mike to activate the Move/Copy command. Once the Move/Copy command is activated, you'll be able to either drag the bodies around by their single directional arrows, or you can always type out exact distances in the dialog box. One advantage to moving parts away from each other is the fact that you can add registration pins in order to make the parts fit better if you plan on gluing them together after they're printed out. Now you can click that info icon in the upper right hand corner of this video to watch my two-part mold video where I demo how to make some simple registration marks. I'll also put that video on this tutorial's resource page at productdesignonline.com/9. Last but not least, since you stuck around to the very end of this video, I wanted to take a few minutes to show you some helpful tricks. Let's take a look at one way to create interlocking joints, which will give you better results when gluing up multi-body 3D printed models. Up until this point, we've been splitting models directly in half with clean, straight cuts. Sometimes this method is useful, especially if you need that surface to be flat on the build plate. Whereas other times, we'd be better off with having interlocking pieces. Interlocking pieces can help ensure that the 3D printed models are stronger when they're glued together, especially if they're props or other functional items that are going to be tossed around. For this demo, I've grabbed this sword file from Thingiverse, which is to be used as a prop, not a weapon. Now this file was created by Andrew, and I'll have a link to it on this week's resource page. I'm going to first start by selecting the patch workspace from the workspace drop-down list. If you're using the newer UI, then you'll find the surface modeling tools in the design workspace under the contextual tab labeled surface. I'm going to then hit the keyboard shortcut letter L as in Lima to activate the line tool. I'll click on the XZ origin plane as the plane to sketch on, and I'm going to zoom in on the sword file so it's easier to see the sketch lines. First, I'll simply draw a line straight across the blade of the sword. I'm going to use this line as the baseline for a dovetail joint. I'll then hit the escape key to exit the line command. Then I'll right-click to quickly select repeat line. At this point, I'll click on the line and I'll create a line with a length of 10 millimeters. Then I'll hit the tab key to lock the dimension in place and I'll type out 98 degrees for the angle of the line, as we're going to make this a dovetail joint, giving the model a lot more strength when it's glued together. I'll then create a line heading to the right 6 millimeters, where I'll click to place this line, making sure that it's horizontal. To finish off this shape, I'll create the last line with the same length of 10 millimeters. However, this time, I'll have to type out 82 degrees for the angle. I'll click to place the line, and then I'll hit the escape key to exit the line command. We can now fit about 2 more dovetails on the surface of the blade, so I'll use the pattern tool to save us some time from having to sketch them one by one. I'll select the sketch drop-down list, and then I'll find the rectangular pattern feature. Once the rectangular pattern feature is activated, I'm going to select the top 3 lines that make up the joint shape. Then I'll click on the direction selector in the dialog box. For the direction, I'll select the large horizontal line. Then, I'll change the direction type to symmetric as we need to pattern a copy on each side of the original sketch. After making sure the quantity is set to 3 instances, I'll drag the blue single directional arrow outward until the 3 joints are spaced evenly. Then I'll click the OK button in the rectangular pattern dialog box to confirm the pattern results. Before we can extrude this line into a surface, we'll need to trim away the unnecessary parts of the sketch. I'm going to hit the keyboard shortcut letter T as in Tango to activate the Sketch Trim tool. Then I'll simply click on the bottom lines of each dovetail to trim them away. We can now select the Create drop-down list and then select the Extrude command. It's important to note that this Extrude command in the Patch workspace allows us to create thin surfaces that we can't create with the Extrude command in the Modeling or Design workspace. We can then thicken the thin surface, which I'll show you how to do in just a minute. First, we'll need to select the lines as the sketch geometry to extrude. I'm going to then click on the right side of the view cube so I can see that the extrude goes through the model. Then I'll change the direction to the two sides option. This will let me drag both single directional arrows until the extruded surface extends past the object that I'm trying to cut. I'll drag the right arrow until it extends past the blade, and I'll drag the left arrow until that extends past the blade. Finally, I'll click the OK button to create the extruded surface. If you've watched any of my surface modeling tutorials, then you're familiar with the fact that surface extrusions technically have no real thickness to them. Therefore, we'll need to thicken the extrusion that we just created. I'll select the Create drop-down list, and then I'll click on the Thicken command near the bottom of the list. You'll see that the first option is the Faces selection. If I were to select the extrusion in the Canvas window, then I'd have to select each face one by one. Because we want to select the entire extrusion, we'll be better off selecting the entire surface body in the Fusion 360 browser. I'll toggle open the Bodies folder in the Fusion 360 browser, and then I'll select the surface body, which is indicated by the orange surface body icon. You'll notice that selects the entire surface extrusion at once. We can then enter a thickness for the extrusion. This part is really important as the thickness that we create will be used to split the body in half. Therefore, we'll have to account for a small tolerance for the 3D printed part to be able to fit together. I found that 0.2 millimeters seems to work well when piecing parts together. However, you may have to experiment with your 3D printer as this can vary based on several different factors. Once I've typed out 0.2 millimeters for the thickness, I'll click the OK button in the dialog box. We'll now want to use this really thin solid body to split the file with the split body command. I'll select the Modify drop-down list, and then once again, I'll activate the split body command. I'll select the blade body as the body to split. Then I'll select the splitting tool selector, which will let us select the dovetail extrusion. Again, you're best off selecting it in the Fusion 360 browser to ensure you select the entire body. I'll also make sure to select Extend Cutting Tools to ensure that the cutting tool extends through the entire blade. Lastly, I'll click the OK button. You'll now see in the Part 1 component folder that I have two bodies of the sword with a dovetail joint that will help reinforce these parts as they're glued together. The last tip that I'll show you is that after you create one joint in your model, you'll be able to copy the body to quickly create more joints of the same type. I'll select the body in the Fusion 360 browser. Then I'll right-click and select Move/Copy. I'll be sure to first select the Create Copy checkbox at the bottom. Then I'll drag the single directional arrow down towards the rest of the blade. After clicking OK to create the copy, you would have to then repeat the split body command and its respective steps. I should also point out that I like this dovetail joint for most 3D printed parts. However, you can follow this same process by making several different shapes or joint types to split your model. Ultimately, the joint type, where you place the joints, and how you split the model up will depend on your particular project and the 3D printer that you're using. If you made it to the end of this video, then let me and the community know by commenting below any tips or tricks that you like to use when preparing or splitting models for 3D printing. Lastly, I want to give a shout out to this week's patrons that joined us on the Product Design Online community. Thanks to Brian Hogger, Thistledew, and Antonio Balcazare for supporting all the Fusion 360 content that I make. As always, I truly appreciate you taking the time to watch this tutorial. If you've enjoyed this tutorial, please click that thumbs up icon and click on that playlist in the lower right hand corner to watch more 3D printing related tutorials. To be part of the Product Design Online community, be sure to check us out on the Patreon page by clicking that Patreon logo right now.